Hello everyone, today we will be discussing about SP2 hybridization by taking an example of ethene. The formula of ethene is C2H4, so which belongs to an alkene family. So let's first do the structure of ethene. So we have two carbon atoms, so two carbon atom having a double bond, ene, so there will be a double bond, and four hydrogen atom, so two in one terminal and two in other terminal. So this is the structure. So now how this particular ethene is following SP2 hybridization, we will be learning in this particular video in detail. Okay. So let's go with the hybridization in ethene. So by taking carbon, so we have two carbon in each carbon. This is the hybridization it undergoes. So carbon atomic number is what? 6. So what the configuration of carbon is 1s2, 2s2 and 2p2. So this is a general electronical configuration of carbon. So now let's see in the ground state. If you see, we have, this is K shell and this is in the L shell, the next valence shell, 2s and 2p in the L shell. So only the valence electrons we have to take. So now we have 2s, which is having 2 electrons, so 2 in opposite spin, and we have 2p. 2p can be further made it as px, py and pz. We have 3p d-gen2 orbital, px, py, pz. And how many electrons we have in 2p? That is 2 electron, 1 and 1 in each. So we have to partially fill, then only we should start completely filling, but since I have 2 electron, I just fill this much. So this is in the case of ground state. So in excited state, what happened? One of the electron from 2s is going to jump into the empty orbital in case of pz orbital. So one electron will be remaining in 2s. The other electron is shifted to the next empty orbital of 2p. So as usual, one electron which is already there in px, another electron in py, and the electron which is jumped into the empty orbital is pz. So this is in the case of excited state. So now this is the final electronical configuration. I mean, this is a distribution of electron taken place. Now let's see how this hybridization is created by this carbon atom. So sp2, the word hybridization, sp2 itself is very clear. 1s orbital, that is 2s 1s orbital, and 2p orbitals, that is these are 2p orbitals. So 2p orbitals will involve to form an sp2 hybridization. So sp2 hybridization. So as we already know, the shape of s orbital is spherical, and the shape of the p orbital, that is px, okay, which is on the x-axis, px, and we also have a py, okay. So these are the three parental orbital which is involved in hybridization, but pz is not involved in the hybridization, so that we will replace it as it is. So only we have our 2s, and in p2p we have px and py only involved in the hybridization. Since three parental orbitals are involved in hybridization, we will get how many hybrid orbital? We'll get 3 hybrid orbitals. So the hybrid orbitals will look something like this. So we will get 3 hybrid orbitals. This pz, keep it as it is. In the final structure, I will put them. Okay, now this 3 new sp2 hybrid orbitals will arrange themselves in such a way they should look something like this. Okay, so each carbon atom, this is for each carbon atom. Since I have 2 carbon atom, each carbon atom is having sp2 hybridization. So each carbon atom is undergoing sp2 hybridization. So one orbital, one sp2 orbital, and the other one is here. So it looks like this. Okay, so other carbon atom, again this, here one sp2 and here one sp2. Okay, so this is how it looks, and each having one electron, and this carbon is also having 1 electron. Is that clear? Now we have this pz, which was not involved in the orbitals. Okay, it was not involved in the hybridization, sorry. So it was not involved in hybridization, so that pz orbitals, so since it's not involved in hybridization, it will have a proper dumbbell shape, so that you have to orient in this manner. So 2 carbon atoms. So for each carbon atom, one pz orbital is not involved in hybridization. So that I'm going to represent in this manner. So each is having one electron. So when they both combine, it looks something like this. And this, obviously there's no electron here. Now, if you see, this is first carbon atom and this is second carbon atom, and each carbon atom should have 4 more electrons. It's already having 1, 2, 3. Okay, so it requires 4 more electron. 1 electron is got from this carbon atom, and these 2 carbon also should be satisfied by these hydrogen. And as we already know, hydrogen configuration is 1s1, so it is having only 1s orbital. So 1s is having a spherical shape. So this is my hydrogen with 1s orbital. So it is having 1 electron. This is 1 more hydrogen with 1s. Again, similarly, the next case also 1 more carbon with where it is hydrogen is coming in contact here. Okay, so therefore they are satisfied. So now what type of bond is expected between 1s and 1 sp2 hybrid orbital? We have sigma bond. Again here we have sigma, sigma and sigma. In this case also, when two p orbitals are lying on an axis, when two p orbitals are lying, they always form a sigma bond. So they have one sigma bond. But then if the p orbitals are lying parallelly with each other, so like this, so they form a pi bond. So here expected is 1 pi. So altogether 1, 2, 3, 4, 5 sigma bond and 1 pi bond. So let's come back to the structure. So this is 1 pi, sigma, 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 sigma bonds. So the number of sigma bond and number of pi bond count is very important. And this particular structure, the bond structure, should be same as per your hybrid structure. So now apart from this, what are the important questions can be expected in this topic? The shape. So shape, what is expected here? Just look into this carbon atom. So I will just highlight this. So it is basically, so it looks like this. So it is triangular planar. The structure is triangular planar or trigonal planar or triangular planar is the shape. So this can be asked for 1 mark question. So and also, what is the bond angle? So if you see, the bond angle is 120. Okay, so 120 degree is the bond angle. So remember the bond angle. Angle is 120 degree, followed by composition of SP2. Okay, so for 100% we are doing the composition. So we have 1s and 2p. So the composition here it is 33.3% of s character, and remaining is 66.6% of your p character. So these are the important questions, also can be expected for 1 mark. So kindly focus on this particular concept. So hope this is clear. Thank you.